Okay, pre-cal, we are going to continue talking about graphing polynomials. So I'm going to start with this example 3 here. My degree is 3. My leading coefficient is positive 1. That means that my end behavior is down, up. So I know no matter what else this graph does right now, I know that its end behavior is set. Okay, so I am going to look at my y-intercept. This equation does not have a constant, so that means my y-intercept is at 0, 0. All right, now we're going to factor this, so I can factor out an x from both terms, and I end up with a difference of squares that will factor again. Okay, so I've got 3 factors. That means I've got 3 solutions. All right, that's exactly what that means. And if you want to write them in ordered pairs, they're 0, 0, negative 3, 0, and 3, 0. It should make perfect sense to you that there are 3 solutions because the degree of this polynomial is 3. Okay, so let's talk about how many terms it should have. It should just have 2 terms because the degree is 3. All right, so let's figure out what's happening here. Well, I've already labeled the y-axis or the y-intercept, and that takes care of that solution right there. So I've also got solutions at 3, 0, and negative 3, 0. And I know what my end behavior is going to look like. So I am just going to come up here. It's going to cross, dip down, cross again, and there you go. So is that 2 turns? Let's use a different color and see. So I'm going to go up here, turn, turn, woot woot, we're good. All right, let's look at example 4. The nice thing about example 4 is that it's already factored for you. But the bad thing about that is that we have to figure out the degree. So if you will look at this first set of factors, notice there are 3 of them. So that means this term's going to be x cubed, and then we're multiplying 2 more x's to it. So the degree here would be 5. And the leading coefficient, of course, is positive 1. So with an odd degree and a positive leading coefficient, our end behavior is down up. All right, so let's continue and look at the y-intercept. Okay, now with this particular problem, if I let all of the x's be zeros, okay, so that would be a 0, that would be a 0, that would be a 0, I'm going to be left with 2 to the negative 3, which would give me negative 8, times 3 times negative 5. So this seems a little odd probably to you because it's a huge number. It's 0, 120, but we don't care because we don't have to draw this to scale. I'm just going to plop that right there and say that that's 0, 120. That's all I got to do. All right, so now it's time to find our solutions from our factors. So I've got x minus 2 to the third. So x minus 2 equals 0 gives me x equals 2. So I've got a solution of 2, 0 with a multiplicity of 3 because it's cubed. Okay, so that's a solution. All right, the next factor is x plus 3. So that gives me a solution at negative 3, 0. And then my last factor, set it equal to 0, and I've got 5, 0. Okay, so let's look at this. I've got 3 solutions at 2, 0, 1 solution at negative 3, 0, 1 solution at 5, 0. That's 5 solutions. Does that make sense with your degree? Yes, it does. And how many turns will we have? 4. Okay, this one's going to get ugly. Just throwing it out there. You're going to do your best, though. It's going to be fine. All right, so I am going to mark 2, 0 right there. 2, 0, and I'm going to have multiplicity of 3. So since it's odd multiplicity, that means that I am going to, it's going to cross, but it's going to kind of flatten out when it crosses over. All right, so I've also got a -3, 0, and I've got a 5, 0. Okay, so what is this going to look like? And again, pay attention to your end behavior, okay? So I'm going to have something like this. Turn 1, 2, 3, 4, just like that. Nice. See, it wasn't horrible. See, it doesn't have to be perfect, so don't try to make it perfect or you'll go crazy. All right, so let's do that again. Let me show you. We go up through here, turn, 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 turn. So there's 4 turns, just like that. Easy peasy lemon squeezy. All right, last one here that's like those. So our degree is 4. Our leading coefficient is +3. So we've got even degree, positive leading coefficient. We got up, up here. So I know no matter what else this does, it's got up, up. End behavior. Okay, the y-intercept is at 0, 0 because we don't have a constant. We're going to have to factor this. So I am going to look at factoring out a -3x squared. And that leaves me with a +16 minus x squared. So that's going to be weird. This is a difference of squares. So I've got 4 and 4, x and x, positive, negative, just like that. So my solutions, I want you to notice that if I've got a degree of 4, I've got 4 solutions. So this 3x squared, if I set this equal to 0, divide both sides by -3, end up with 0. The square root of 0 is 0. So I've got a solution of 0, 0, multiplicity of 2. And then each of these I will solve. So 4 minus x equals 0. So x equals 4, and then this one right here would be x equals -4. So my solutions are 4, 0, -4, 0, and then multiplicity at 0, 0. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. There we go, just like that. Okay, we've got a degree of 4, so our turns are going to be 3 turns. All right, so I know this has to go through here. I've got multiplicity here, so since it's dipping down, it's going to touch from the other side. Just like that. Okay, let's do it again in another color so you can see it. So I've got this, turn, turn, turn. Yay! All right. Okay, this last one, consider a graph that is transformed by f of x minus 2 minus 4. What would the coordinates of the relative maximum be? Okay, this is a little weird, all right? This problem is a little odd, but don't worry about it. Just bear with me here. So if I've got an ordered pair at 2, 5, oh, that's what's wrong with this problem. I didn't have a graph on here. I forgot about that. We will look at this, okay? I just forgot to give you a graph. 1, 2, 3, 4, 5. I know what it's supposed to look like. 2, 3, 4, 5. Okay, your graph looks something like this. No, God, I hate it when it does that. Sorry, kids. Okay. Well, I'm just messing this up all kinds of ways. That's nice. It looks something like that. Okay, so we have a maximum value, a relative maximum, because we've got this peak right here, and this ordered pair is at 2, 5. All right, so if we transform it by this transformation right here, that means right 2 and then down 4. What would that look like? That is essentially what we're looking at. So it's not quite the struggle that drawing it was. All right, so if I move down 2, or sorry, over 2, and then down 4, okay, so that's going to be 1, 2, 3, 4, and 1, 2. This ordered pair right here would be translated to 4, 1. So that would be your answer. You're essentially just moving that relative maximum, that peak at the top of that crest right there. You're just actually moving it right 2 down 4. So that would be the new coordinate. I know, it's super crazy.